Hello everyone and welcome to our presentation. Today we are presenting our network analysis of Pakistan's consumer price index from 2023 to 2026. By utilizing graph theory and centrality metrics, we aim to decode the hidden drivers of inflation in the Pakistani economy. I am Hassan Saad and joining me are my colleagues Muhammad Saad and Ahmed Beg. Please click to slide number 2.
Great.
So, first of all, I am going to discuss the methodology and framework. To tackle this, we designed a rigorous three-phase methodology: data engineering, graph architecture, and centrality analysis. I will walk you through the data processing. Saad will explain the mathematical architecture of our networks, and Ahmed will finally discuss our final 2026 findings and model robustness. Now, please click to slide number 3. Now, I am going to discuss the phase 1. Our dataset consists of 35 months of PBS CPI data spanning 17 major cities. Real world data is rarely perfect. So, our first challenge was handling systematic gaps, specifically a complete missing record from February 2024. Rather than dropping the data, we wrote a Python script to perform temporal average between January and March 2024 to cleanly impute the missing month. Once our dataset was whole, we calculated the core metric of our entire project, the month on month, the price delta for every single item across every city. This gave us the exact price fluctuation vectors we needed. Please click to slide number 4. Now, I'm going to discuss the Pakistan inflation volatility. If we look at the macro view of this data, we see extreme volatility. We recorded a dramatic inflationary spike in mid 2023, followed by a stabilization period and a newly emerging upward trend and a newly emerging economy like thing as we move into 2026. But traditional line graphs don't tell us how these price shocks spread from one item to another. For that, we turn to network science. I will now hand it over to Muhammad Saad to explain our graph architecture. Thank you so much.
Uh, Thank
भाई
you,
ये
Hassan.
pause करते हैं.
Thank you, Hassan. To understand how inflation spreads, we didn't just want to know if prices went up. We wanted to know which commodities move in perfect mathematical synchronization. In phase 2, we built Python scripts to construct a mathematical web. We used cosine similarity to compare the price delta vectors of different items. To ensure our network was highly accurate, we applied strict thresholds. First was the tau threshold. We required a minimum cosine similarity of 0.8. This means two items had to move in at least 80% synchronization within a city to even be considered a match. Second was our case threshold. To prove this was a national trend and not a localized anomaly, this 80% synchronization had to happen simultaneously in a minimum of 5 different cities. If both conditions were met, our code drew an edge between those two commodities. Next slide, please. When we ran this logic across our data, we generated intricate year-by-year network graphs. In these webs, the nodes represent individual CPI items like wheat, electricity, or clothing. The edges connecting them represent highly correlated price shocks. By mapping the economy this way, we moved away from simple spreadsheets and created a structural map of Pakistan's inflation. I will now hand it over to Ahmed Beg to reveal what this map tells about the current year, tells us about the current year 2026.
So thank you, Saad. So now I will discuss slide number 8, which discusses the analysis of the results. Once our networks were built, we initiated phase number 3. We applied network analysis algorithms to calculate degree, closeness, and betweenness centrality for the year 2026. Now I shall move on to slide number 9, which discusses the 2026 centrality rankings. So degree centrality measures the sheer volume of strong synchronized connections a node has. Looking at our 2026 results, the top drivers of inflation are not staple food items as one might expect them to be. Sitting at very top with the highest degree centrality is high-speed diesel, followed immediately by local cement and LPG. This mathematically proves that in 2026, when the prices of fuel and construction materials experiences a shock, that shock ripples through the highest number of our commodities in the economy. Now I shall shift to slide number 10, which discusses a sensitivity analysis. Now, as data scientists, we had to ask, are these results real or are they just a byproduct of how we weighted our graph, To test this, we conducted a sensitivity analysis. We completely rewrote our edge weighting scheme. Instead of weighting edges by simple count of cities, we updated our Python script to weight the network based on average cosine similarity. We reran the entire multi-year calculation. The result, the rankings did not break. High-speed diesel and cement maintained their exact positions as the number one and number two drivers of the market. This was our surprising moment, or aha moment, as one says. It proves our network model is highly robust, mathematically sound, and not artificially biased by our initial weighting choices. Now I shall move on to slide number 11 and finally slide number 12, which is the concluding part. Ultimately, our network analysis provides a clear strategic insight. Energy and construction are the true anchors of Pakistan's current inflationary web. Policies aimed at controlling retail food prices will likely fail if underlying nodes, diesel and cements, are left unmanaged because they are the primary transmitters of economic volatility. Now, moving on to the last slide, slide number 12. This concludes our analysis. Our methodology allowed us to take raw, chaotic CPI data and transform it into a proven, robust mathematical model of the Pakistani economy. Thank you for your time, and we should be happy to answer any questions. So now you can drop the questions in the comment section below. Thank you.
Thank you
Thank
so
you,
much.
guys.